This is section 9.2, developing formulas for circles and regular polygons. These are the objectives. Develop and apply the formulas for the area and circumference of a circle. Develop and apply the formula for the area of a regular polygon.
This is the vocabulary: circle, center of a circle, center of a regular polygon, apotheme, central angle of a regular polygon. Next slide.
Let me read this. This is the definition of a circle. It says a circle is the locus of points in a plane that are a fixed distance from a point called the center of the circle. A circle is named by the symbol that you see there. It kind of looks like a bull's eye and its center. Example of this. This, if you want to name the circle, is right here, circle A. And this circle has radius AB, diameter CD. Terms that you're familiar with. And just another note, if you did not know, now you know. Pi is an irrational number, something you should have seen in Algebra 1. And this is how we define pi. You can go ahead and read it. Let me go ahead and move on to the next slide. Formulas actually. The circle with diameter D and radius R has a circumference that you see here. Either pi times D or circumference is equal to 2 pi R. And then the area is pi R squared. And again, these are formulas you have seen. Now, you might be asking yourself this question. I'm almost 100% sure. This is where it comes from. If you look at this, it says divide the circle and rearrange the pieces to make a shape that resembles a parallelogram, sort of like a pizza slices. Once you rearrange them to look like this, notice that this looks like a what? It looks like a parallelogram. So how do we find the area of a parallelogram? Is base times height. You saw 9.1. So what is the base? Pi r. What is the height? R. And this is why we have pi r squared for the area of a circle. Let's move on to the next slide. It says find the area of circle K in terms of pi. Formula is right here. So when it says in terms of pi, that means that you're not going to multiply pi. You just leave it alone. And the answer is going to look like this. Substitute r, which is 3, not 6. 6 is the diameter. And that's how you end up 9 pi. And again, when it says in terms of pi, that means that you leave the pi alone. And then this is inches, so square inches for area. Number 2 says find the radius of a circle if the circumference is 18 pi centimeters. So we're looking for the radius. We're going to use the formula for circumference, which is equal to 2 pi r. I substitute the given information. C is 18 pi. 2 pi, bring it over, and you're looking for r. So what I'm going to do is I'm going to divide both sides by 2 pi. And when I do that, I get r is equal to 9 centimeters.
This is practice problem number 3. Follow along as we read the problem. A pizza making kit contains 2 circular baking stones with diameters 24 centimeters and 48 centimeters. Find the area of each stone, round to the nearest tenth.
My voice is changing here. A 24, so here's part A. So we're looking at the 24 centimeter diameter. Notice that we're looking for the area. So I'm not going to use diameter, I'm going to use the radius. So that's why we have to divide the diameter by 2, and we end up with 12 as the radius. At this point, all we're going to do is we're going to substitute radius for the radius is 12, plug it into the formula, and then you simplify this by using the calculator because you need to round to the nearest tenth, and this is what you get, 452.4 square centimeters. For B, now we have a different diameter, similar steps as A. The radius is going to be half of 48, which is 24. Plug it into the formula to compute the area of a circle, which is your pi r squared. Once you substitute r, you get 24. Simplify that by using the calc. Round, and this is the answer. Let's go to the next slide.
This is practice problem number 4. Follow along as I read the problem. A drum kit contains 2 drums with diameters of 10 inches and 14 inches. Find the circumference of each drum. Round your answer to the nearest tenth.
So just like number 3, now there's 2 parts. Now I'm going to be looking at the circumference. So I'm going to be using a different formula. Circumference is pi times d. There's the other formula, which is circumference equals 2 pi r. But since they give me the diameter, it's easier for me to use pi times d. So all I'm going to do is substitute. At this point, punch this into the calculator and run to the nearest tenth. And this is what we get, 31.4 inches. For part B, the diameter changes. It's now 14 inches. Similar steps as part A. And it's pretty easy, just follow along. Once you multiply, you get 44 inches. Here's the next slide. There's going to be some key concepts in this slide. They're going to be used throughout the section and future sections as well, so make sure you understand them. I'm going to be using this figure to describe or to describe those key concepts. First one is, let me follow along. The center of a regular polygon is equidistant from the vertices. In this case, the center of this regular polygon is C. The apothem is the shortest distance from the center to a side. So in this case, the apothem is BC. Let me get a pen. So this is your apothem, and notice that it is perpendicular to the side of the polygon. A center angle of a regular polygon has its vertex at the center. Again, and this is the center, and this is a center angle. Let me highlight it. Center angle DCE. DCE. The last thing, each center angle measure of a regular n-gon is 360 divided by n. So if I want to compute the measurement of this center angle, all I need to do is take 360 divided by the number of sides. In this case, since it's a pentagon, I divide it by 5. So then I have 360 divided by 5, and this center angle will be 72 degrees. Let's go to the next slide, which is going to be a formula. Follow along. Says a regular polygon. The area of regular polygon is the following. The area of regular polygon with given apothem. The apothem, we're going to call it A. And perimeter P is given by this. 1/2 times the apothem times the perimeter. And again, this is the apothem from the center. The shortest distance from the center to a side of the polygon. And again, is perpendicular to the side. Here's number 5. This is where we apply that theorem that you saw on the previous slide. It says find the area of each regular polygon. Round to the nearest tenth if necessary. Here's a picture. Notice that they give you that 15 inches. Recognize that this is the apothem. So to find the perimeter, all I need to do is find the area. All I need to know is the perimeter, which I don't have. So I'm gonna somehow find the perimeter. So let's go through the work. First, I'm gonna compute the degree measurement of the center angle. Since it's a pentagon, this is what I do. 360 divided by 5, which gives me 72. Now, let me get a pen. So this angle here, from here to here is 72. I don't want that angle. I just want this angle from here to here. Let me just do this. That angle is going to be half of this, which is actually 36. Let me get rid of that. So the angle here is 36 degrees. Why do I want that? Because I want to be working with this right triangle that you see here. And you'll see why in just a little bit. Now, if this is 36, I know that this is 54. Now, from here, I am going to basically find this distance from here to here. So I'm going to call that x. At this point, I am going to use a trig ratio. And this is the following trig ratio that I'm going to use. Using 36 as my reference angle, I have opposite and adjacent. That's why I have tangent at 36. You know how to solve this. Make it into a proportion, cross multiply. You end up with this, 15 times tangent at 36. Once you multiply, you end up with 10.9 if you round. Now at this point, the distance from here to here is x. So now I need the distance from here to here, which is the side of this regular polygon. So I'm going to call that s. How do I find s? I multiply x by 2. Here's my x. And I end up with 21.8. So this is 21.8. This is 21.8. And going around this pentagon. So how do I find the perimeter? 5 times 21.8 is 109. So now I know the perimeter, the apothem is given to me, so I can apply my formula. Area equals 1/2 apothem times perimeter, and substitute, multiply, and this is my answer once around to the nearest tenth. There's a lot of steps, but it's nothing too complicated. You just have to remember what are the steps that you need to do first, second, and so forth. Let's go to the next one, number 6. So you can read the directions, look at the picture. Now you have a triangle, an equilateral triangle, and this is what we're going to do. I want you to copy this problem, and we're going to finish this in class. Just in case you want to give it a shot by using what you learned from problem number 5, this is what you get after you round. If you don't, it's okay, we'll go over it in class. But try it. Same thing for number 7. Copy the picture and we'll do this in class. Just in case you want to give it a shot, this is what you should be getting. And this concludes video, this concludes video 9.2.